NVIDIA is one of the worst, most annoying companies to deal with right now. I wasn't particularly excited for Blackwell to begin with, but I'll admit that I didn't predict how much of a disaster this generation's launch would be. However, monopolies are still monopolies. Just give it a few months and everyone will eventually forget about all of this, especially after Jensen announces whatever their new artificial novelty feature will be, and he'll find a way to justify locking the feature to the newer generation of cards, because true innovation is making your previous products obsolete by indoctrinating your video game companies into integrating useless proprietary features that they assure to you can only be achieved using their latest hardware. By the way, you want to hear a fun fact? Sherlock Holmes The Awakened, a game that I intend to play eventually, only has support for DLSS. So if you have a handheld device like the Steam Deck, ROG Ally, or the Lenovo Legion, and you wanted to explore your graphics settings with the upscaling presets, then you can go fuck yourself, my dear sir. You're gonna have to deal with Nvidia's bullshit proprietary vendor lock with their cutting edge features, quote unquote. But you know what? I think there might be a way for me to not deal with any of this nonsense, but before I can do that, unfortunately, I have to retire my Hannah Montana OS. So, you guys remember the video I made years ago about writing my own Hannah Montana OS inspired operating system? Because it wasn't literally Hannah Montana OS. I don't think it's even possible to install that in modern hardware. Regardless, yeah, I have a little bit of a confession. That build was actually nuked a long time ago, mostly because the drive I had installed that in was having weird spikes in the read and write speeds, so I ended up replacing the SSD. This happened over a year ago, but over time I ended up installing those same Hannah Montana OS desktop themes on my test VM. So to give a little bit of a context, I have a virtual machine set up with Arch Linux installed, and that mainly exists so that I can either perform a few benchmark comparisons, but most importantly, it's so that I can use it as a testing environment whenever I want to use a specific piece of software that I didn't obtain from an official repository, and I can't 100% be sure if it'll work as intended, or if it might have some malicious code in it. The VM was also useful for experiments with really bleeding edge stuff that was often found in the testing repositories like core testing, extra testing, and KDE unstable. Now normally for this video, I would actually use this VM to test out something that I believe might potentially help me to get FSR to work on Sherlock Holmes, but unfortunately, I've been very storage constrained. I installed this OS on a 240GB SSD, thinking that it would be enough, but I severely underestimated how fast I eat up storage when I'm experimenting with so many things at the same time. For a while, I was willing to put up with it, but when I'm getting to a point where I have to install 80GB video games, I eventually realized, okay, I think I need to replace the hard drive. And I did, and now I have to install Arch Linux again, which is fine. I torrented the ISO, which by the way, you should always torrent Linux ISOs. There's no need to use the magnet links. Just install a torrent client like qBittorrent. But anyway, now it's time to play around with Fort Manager. Right before I do that, let's get back to the topic of the video. So yeah, I don't like NVIDIA. In fact, I've never owned a single GeForce card. I do own hardware that technically has NVIDIA chips. For example, my PlayStation 3 has an RSX, which is NVIDIA hardware, and I also have a Nintendo Switch, which is also technically speaking NVIDIA hardware. I also have an old junk laptop that I bought for 20 bucks a couple of months ago. It's a very old laptop. It was literally running Windows XP before I purged it. And apparently it has a GeForce chip in it, but that really had no bearing on my decision to buy it. I just did it out of interest in collecting old shit. But as far as desktop discrete GPUs or gaming laptops, I've never bought any GeForce cards, and to be honest, I probably never will. Because one of the biggest pet peeves that I've always had with NVIDIA is that for some fucking reason they don't open source their drivers. They have open sourced their kernel modules, and they seem to be contributing some commits to the community built NVK driver, but their actual graphic drivers, their software stack, is largely proprietary. So this means that if you're a Linux user and you own their GPUs and want to get the best experience with all of the features, the essential features that they use to market their products, you're essentially beholden to NVIDIA. With AMD, since a lot of the software is open source, it's a lot easier to debug their code, you can fork it, you can even make a better version of their Vulkan driver, which the community did. But with NVIDIA, well, good fucking luck. You know how recently people have been complaining about their drivers being dog shit ever since they launched the 50 series? Yeah, we've been experiencing that for fucking eons, and even to this day, it's not like things are perfect. For example, I run a bleeding edge distro, I fuck around with experimental software, and NVIDIA, I swear to god, it's like they are fucking allergic to bleeding edge software. You have to assign 10 million prescriptions and antibiotics in order for it to work. But speaking of bleeding edge, I have to install Arch Linux on my drive. So we're gonna have to create a new virtual machine. We're gonna select the ROM, which by the way, always use the most up-to-date ROMs. I'm gonna give myself 16 gigabytes of RAM. So far I haven't felt the need to add more than that. For the CPU, I'm gonna give myself one, but I'll edit that at a later time. Now for the first step, you have to uncheck the option to enable storage. Don't worry, we'll get that to a later time. And now let's customize the configuration before install. First of all, you have to change the firmware to EFI. If you don't do this, I'm pretty sure the PCIe pass-through just won't work. Now for the CPU topology, I'm gonna give myself 8 cores and 2 threads for each core. Now if I was installing Windows, I actually wouldn't be doing this because Windows is a bit more sensitive with cross-CCD latency with Ryzen 9 processors. There are smarter ways to customize the core topology and core pinning in order to maximize the performance, but a lot of that is not really necessary with Linux. The scheduler is a bit better on that department. Anyway, now it's time to pass through my drive. Now, there are a couple of ways that you can do that, but this is my preferred way. Open the terminal, type ls/dev/disk/by-id/, and by doing this, you'll see a list of all the connected drives based on the ID. I know mine is the one called ADA-team blah 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 so on so on. So after that, you need to choose the option for select or create custom storage, and then you type /dev/disk/by-id, and then you paste the ID of the SSD that we got from that list. You also need to make sure the device type is disk drive and that the bus type is SATA. After that, I think we can start installing Arch Linux. Okay, so for starters, we have to zap the SSD. Funnily enough, I think it used to have Linux Mint there, but no, we're installing Arch Linux. So let's first type lsblk in order to list all the drives. Since we only have one SSD passed to the virtual machine, we're only going to see SDA. If we had an NVMe drive, you would probably see something like NVMe ON1. Now, you may also have spotted SDA1, SDA2, and SDA3. Those are just separate partitions from the old operating system. That's actually the reason why I want to erase the SSD. To do that, you can type gdisk/dev/sda, then press X for export command, then Z to wipe out the GPT. Confirm at least 2 times, and there you go. The drive should be clean. Now it's time for the fun part. Let's launch the Arch install script in order to accelerate and streamline the installation process. Now I'm not changing the language and locale. For mirrors and repositories, you will need to make sure to select the mirror regions that match your country, which in my case it's Portugal. Then we go to this configuration. I usually prefer going with best effort default partition layout, and then we select the correct drives, which in my case, it's the only drive available there. For the file system, if you want to be unique, pick whatever you feel like, but you should probably go with ext4 just for safety. No, I do not want to create a separate partition for home. I don't really care. I don't need disk encryption. This is a test VM. Swap, on the other hand, it's pretty good to have. You can make sure it's enabled. For the bootloader, there is one reason for why I would use systemd boot, but it's not really relevant for the setup, so I'm gonna go with grub. Then you can set up the root password, then add a user. Mine will be named Archie, and then you can add him as a sudoer. Now for the profile, this is gonna go down to personal preference. I'm a KDE Plasma user, so I'm gonna go with full desktop environment. For the graphics driver, it's probably best to select all open source. Obviously, if you have an NVIDIA GPU, you might want to select one of those 3 options, but I don't, so I'm gonna go with the all open source. For greeter, I'm gonna leave it with SDDM. It's what I need for Plasma anyway. Now for audio, I'm a Pipewire dude, so I'm gonna go with that. Kernels, I usually install the Zen kernel, but I'll leave that for different times. For the network configuration, you should always pick Network Manager. Now the additional package stage, last time I used this script, it actually wasn't like this. I had to type out the name of the package. I can't say I like this change a whole heck of a lot because there's no fucking way I'm scrolling through all of this, but whatever. For the time zone, I live in Lisbon, so based on that, you might have to scroll through a bit. Automatic time sync, sure, keep it enabled. And after this, we can just hit the good old install button and hope nothing bad happens in the process. Speaking of bad, what was the topic of the video again? Oh yeah, NVIDIA. So at this point, everyone knows NVIDIA is just evil. They have abusive relationships with their board partners, they manipulate the market, they lie, they overcharge, they apparently blackmail and extort the media. But all of those are obviously bad things, but sometimes I wonder if I could maybe find myself in the mindset of the average GeForce user, which is essentially, yeah, I hate the company, but I need their GPUs. Their competitors just can't achieve what they offer. But the thing is, a lot of the areas that Nvidia supposedly excels at relative to the competition are features that I think fucking suck. Like ray tracing, literal waste of technology. It's awesome for animated movies and tech demos, not as good for gaming. It creates noise, it's too expensive, severely tanks your performance, forces you to use temporal upscaling and anti-aliasing solutions if you want to recover performance, which ends up turning your game into a blurry, shimmery mess, all just for the sake of creating a realistic lighting environment that more often than not pales in comparison to what Need for Speed 2015 had to offer 10 years ago. So other than ray tracing, what are the other features that they apparently have an advantage in? G-Sync? No thanks. Reflex? Don't need. Frame generation? I'd rather shove a cactus up my asshole than deal with fake frames. The only feature that I genuinely treasure from Nvidia is DLSS because I actually do see value in AI-based image upscaling, not even just exclusively for gaming, but since DLSS is proprietary, I can't be bothered to give a fuck. And even then, I can't exactly say I have much respect for video games that heavily rely on upscaling. While I don't mind upscaling technology being recommended for really high resolutions, I think it's a much different story when even at 1080p, which is where the upscaling solution tends to show its flaws the most, the game is somehow expecting you to use an upscaler because apparently they've made such a huge technological jump when transitioning to the 9th generation, and yet those same games that have all of the ray tracing, all of the Unreal Engine 5 shenanigans, they swear to you that you desperately need an upscaler, maybe even frame generation, in order to experience this new era of video game graphics. It looks like this. Brother, I am not enabling an upscaler for this. The only thing I'm enabling is my refund request. Anyway, I think Archie is done installing. Now I just gotta do a few additional changes to my VM, mainly to isolate my mouse and keyboard, but most importantly, my GPU. My non-NVIDIA GPU. Yes, I'm that petty today. This isn't even my main computer. My actual primary PC has an RX 6900 XT. This computer that I'm using to set up this VM is a separate PC that I built exclusively for hypervisors. It has two GPUs, one of them running on the host and the other one being transferred to the guest VM. Neither of them are GeForce cards, because fuck NVIDIA. I love how Wayland is just the default display server when I install KDE Plasma. It didn't used to be this way when I first installed Arch Linux. Anyway, I don't need to bore all of you with all of the essential packages that I need to install for my day-to-day use case. The most important thing that I want to focus on is the Heroic Games Launcher because I bought Sherlock Holmes The Awakened on my GOG account. Heroic is pretty intuitive for simple library management, so I'm gonna go with that. Now it's possible this might already be fully baked into Linux and its libraries, but I had to install Umu Launcher, which is what is supposed to allow you to run non-Steam games using Proton. Just because Proton has some really weird address points and configurations that are specifically meant for the Steam client, not as much for other Windows applications. Now after installing the game, it works fine. I don't think there are any compatibility issues with Linux as far as I know. You can have a pretty decent time with the game as it is, but I still want to be able to at least have the option to enable an upscaler, which I can't because the game only has DLSS. Now, this can be worked around. So first of all, we need to get this tool called OptiScaler, which you may or may not have already heard of it. And this actually comes with what I believe are reasonable up-to-date DLL files for DLSS, XCSS, and actually separate versions of FSR, as well as a few additional DLL and config files that find a way to trick the game into thinking you're running DLSS when in reality you're running FSR. The only thing you need to do is download the szip file, extract pretty much everything there into the game's main folder, though if it's an Unreal Engine game, you actually have to go to the Win64 folder, which is usually located in the binaries folder. After that, you grab the DLL called OptiScaler, and you make sure to rename it to DXGI. Additionally, you have to locate the NVNGX underscore DLSS DLL, which usually for Unreal Engine games, you have to sort through a bunch of folders. For this game, it's the address that I'm showing on screen. you can do the rest of the work yourself. Also, you have to rename this DLL file into just nvngx and remove the underscore DLSS. Lastly, you need to add a WINE-DLL overrides environmental variable, namely dxgi equals nb. If you're able to follow all these steps, you should be able to get FSR to work on this game. At least in my case, it worked wonders. Now realistically, this game isn't the most demanding thing ever. I could easily see myself rocking a 1440p experience at max settings at native resolutions. But you see, this is what I initially liked about upscalers. It allows my RX 6700 XT to get into reasonably high frame rates at 4K quality. Like I said, the game thinks it's enabling DLSS, but it's actually FSR. In fact, it doesn't even have to be FSR. You can even pick XCSS, which is in some instances a better option than FSR. Now, if you're going to use FSR, I just want to note the FSR 3.1 options seem to be kind of bugged. Like, the non-DX12 option just makes the game look hideous. The DX12 version looks better, but it seems to cause some potential CPU overhead, and my GPU isn't able to be fully maxed out. So this is one of the rare instances where I'll actually recommend FSR 2 over 3. But regardless, 80 to 90 FPS at 4K with my RX 6700 XT, I'm pretty happy with that. Now, there is one thing that could potentially entice me to get a GeForce card. I guess we're still on that topic, which is its advantage in creative applications because of the more widespread adoption of CUDA, but I feel like it's only a matter of time before Radeon catches up to the point where this doesn't really matter, especially now that Rockham will soon have native Windows support. Also, I don't use paid creative applications. I don't buy licenses for big established video editors like Adobe Premiere or whatever the fuck. So my only criteria for GPUs is that as long as it has a hardware encoder that I can use to export videos on Kdenlive, that's all I give a fuck about. Anyway, if any of you Linux nerds in my audience have RDNA 4 cards, do you think it's possible to give me feedback on whether or not you're able to get FSR 4 to work with the OptiScaler? I mean, I know initially you couldn't, but I've been seeing recent threads where people are saying that it finally works on Linux, but I gotta be sure. I may or may not buy a 9000 series card, but a lot of that entirely depends on whether or not I'm able to get FSR 4 to work. But anyway, I think that's really all I have to express. I'm gonna go sleep next to my Hatsune Miku plushies, and I hope you all have a good day.